This is a Micron memory chip. It might be small, but its impact on the world over the last 5 decades has been enormous. Today, not only do Micron memory chips power many of your favorite devices, but our newest generation of chips are enabling artificial intelligence inside smartphones, tablets, computers, and other electronic gadgets around the world. The journey of a Micron memory chip actually begins in our industry-leading R&D, which has earned us more than 60,000 patents since our founding, and into which we continue to invest billions of dollars globally. The memory chip's journey then continues onto the design board. Here, computer-aided design tools help engineers lay out billions of electronic components on the chip. Once designed, now comes the challenging task of actually building the chip, a complex production process that requires thousands of steps and can take up to a month to complete. Following the design and development phase, the chip is now ready to be built on silicon wafers inside a fabrication area called a fab. These state-of-the-art clean rooms are 100 times cleaner than a hospital operating room, which is necessary to ensure the silicon wafers are protected from ambient contamination, such as dust and other microscopic particles. Micron fabs house massive, multi-million-dollar machines that perform numerous intricate chemical processes that transfer the nanoscale chip design onto the wafers. Among the many process areas in the fab, machines in the photolithography area coat the silicon wafer with a photoresistant material. Circuit patterns are then exposed to ultraviolet light. Various compounds are applied to create a layer of circuits, and the excess material is rinsed away. This process is repeated multiple times, gradually building up layers. At this point, hundreds of identical chips are built on the silicon wafer. Wafers are moved between different machines for each step of the process using a robotic automated material handling system, or AMHS. Next comes wafer probing. In probe, initial functionality tests are performed on each chip image called a die on the wafer. Only those chips that pass all the tests continue to the assembly process. When the wafers produced in the fabrication facility arrive at the assembly facilities, they get thinned with a polishing or chemical process that ensures each wafer achieves a precise and uniform thickness. At this point, the hundreds of chips on the wafer are cut into individual die using a diamond edge saw. Based on probe test results, the good individual die are picked by a robot arm from the wafer, where many of them are then placed on a circuit board. In these instances, a gold wire is used to connect each die to the circuit board. The next process encapsulates each die in a protective plastic package, after which it's ready to be shipped for more tests. Every Micron chip undergoes hundreds of tests to ensure it meets the highest quality standards. This is a chip's final set of tests, which includes being put under extreme temperatures and conditions to force any weak components to fail. Additional speed and performance tests are also performed. Chips that pass all of these tests are then named and labeled and finally scanned to verify strict conformance to all specifications. But the journey isn't over yet. Many of Micron's finished chips are used to build memory modules called DIMMs and solid-state drives, or SSDs. Automated surface mount assembly equipment is used to mount memory and other components onto printed circuit boards to create these SSDs. Once Micron chips have been integrated into one of these devices, another round of various heating cycles, tests, and measurements is performed. Only after passing these tests are the finished devices finally sealed in industry-standard anti-static packaging and placed in boxes for shipment to customers. This may be where a Micron memory chip's journey ends, but our journey into the future is never-ending. Fueled by the tenacity and innovative spirit of our people, Micron is a global leader in AI, where memory and storage are critical for machine learning, training, and inference. And through our ongoing investments in fabs in the United States, we're not only building the future of U.S. semiconductor manufacturing and competitiveness, but also driving American leadership in artificial intelligence and technology innovation for years to come.